Okay, so with this lesson, we start to look at a combination of functions. It's not just a single function. Now, what I'd like you to think of is that if we want to find the area between two curves, if ever we found a difference of two things, to say sums and differences, if we ever wanted to find the difference of two things, it would be the bigger thing minus the smaller thing. So if I want to find the difference between two people's heights, normally I take the taller person and subtract the smaller person's height, and we get the height difference. If I want to find out the difference between two people's incomes, you take the bigger income and you subtract the smaller income, and that's where you get the difference from. Well, it's a little bit like that when it comes to curves. If I do a quick sketch here, this is just going to be a kind of make-believe example, but that will do. Alrighty, so I could have maybe a line just going like this. So that's some straight line. I've got no idea what the equation of that line is, but that's function f of x, nice straight line going there. And then maybe I've also got a function that goes like this, and we'll call that function g of x. Okay, so we've got these two functions that we're dealing with, and we might want to find out what the area is that's bounded by those two functions. And quite clearly, this is the area in here that we would be looking for. Here's the basic principles that we'll be looking at. Is you take the two functions and the area is bounded from whatever that x value is up to whatever this x value is. So we need to find the points of intersection. So number one is find the points of intersection of the two functions where necessary. Which in our case, where necessary, means pretty much all the time. So we'll have found the points of the coordinates for these 2 points of intersection, and really all we're principally concerned with are the x values, because we're going to do integration, and we're going to be doing integration with respect to x, although we could do it with respect to y if we had the right types of functions. But in this case, we'll be doing the integration with respect to x, and so therefore we need the x values that form the lower boundary and also the upper boundary for this function. Alright, so find the points of intersection of the two functions where necessary. And now, coming back to how I opened up initially, if you're finding a difference, it's usually the bigger thing minus the smaller thing. From my perspective, between these 2 points, this straight line, the straight line is the bigger thing, it's higher up. To me, that seems to be the bigger thing. And whatever this function is here, the g of x curve, that's the smaller one. So what I would be doing to find the area of this is I would integrate, but I would have this function f of x, and subtract from it this function g of x. This will all make a whole lot more sense when we come to doing examples from the exercise 3.8. So set up the integral such that the upper function, so upper means uppermost of the two curves, the upper function has the lower function subtracted from it. Function subtracted from it. Alright, and use the x values for the intercepts of those two functions as the boundaries of integration, or the limits of integration. Use the x values from, really that should be from the intercepts, use the x values from the intercepts as the limits of integration, or boundaries of integration. We're going to integrate from one to the other. Now clearly when you look at this one, if we're trying to find this area in here, then function f of x is the uppermost function, and function g of x for that range, for that domain I should say, is the lower function. If I happen to step outside of that, beyond here, then you would see that for a different domain, now g of x over here would be the upper function and f of x would be the lower function. And in the same way over here, if I step to the left of this point of intersection, then again, g of x would be the upper function and f of x, function f of x would be the lower function. Now let's just assume that the x value for this is a, and I don't know what the y value is, it looks like it's 0, but it might not be. And then let's assume that the x value for up here is b, and again I don't know what the y value is, but we'll assume that it's some number that we can work with, but it doesn't really matter to us because we don't need to use that in the integration. So the area for this curve, between these two curves would be the integral from a to b, and then we take the upper function, which is function f of x, and we subtract from it function g of x, and we do all of that with respect to x. And really, that's all there is to it. You just plug those functions in, and if there's like terms that cancel or add together, you take care of all of that, you integrate the two functions, you integrate what's left over, and then put the limits of integration in to evaluate what that will give you. So we're going to start with exercise 3.8,